let's look at an example like that. Let's suppose we've got y of t equal to, let's say, I don't know, t cubed plus 2. Let's find the average velocities for, let's say, 0, 0 to 3, 0 to 2, and 0 to 1. And then contrast against the instantaneous velocity. Instantaneous velocity at time t equals to 0. Which, by the way, by definition, that is y prime of 0 is the instantaneous velocity, okay? Okay, so how do you calculate average velocities? Let's see here. So for 0 to 3, what's the average velocity? What you do is you calculate the change in y divided by the change in t. What's the change in time here? If you're looking at an interval from 0 to 3, there's 3 units of time, so we divide by 3. And then y, what do? We got y of 3 minus y of 0. What's that equal to? What's 3 cubed? So we got 27 plus 2. Oh yeah, 27 plus 2 is 29, and then minus y of 0, which is what? I don't disagree with you. I just wrote 29 a different way. So we end up with 22 plus 2 minus 2 divided by 3, which is what? 9, right? And it's 9 SpongeBob's per fortnight. No, let's say meters per second. That seems like a more, or you guys want feet per second? I don't care. It's America. You can have your way if you want.
Where did you get the, I know we got 27, where did you minus?
Y of 0 is 2. So yeah, by the way, here's y of 0 is 2. Y of 1 is what? 3. Y of 2 is 8 plus 2, 10. Let's see here, what else can we just get it out of the way? Y of 3 was 27, okay. Now, so here I'm saying in meters and seconds, okay, just to make it more interesting. You can make it miles and hours if you want, I don't care, whatever.
3 is 7, or 3 is 27, and then I saw 0 is 2. But where did you get negative 2 after that?
The change in y is the upper y minus the lower y. So the lower y is 2, subtract 2. 0 to 2, what's the average velocity there? So again, change in y over change in t, but this time that's y of 2 minus y of 0. And the change in t is not 3 anymore, it's what? It's 2. So what's that? Well, y of 2 is just 10, so I've got 10 minus 2 over 2, which is what? Yeah, so we get 4. And I'll stick the units on it at the end just to make it more interesting. Now the average from 0 to 1, what do we got? Y of 1 minus y of 0 divided by 1. What's y of 1? 3 minus 2 divided by 1, which is what? 1 meter per second. So as you can see, even if we pick one time like one time post, like one fixed time to measure average velocities with respect to, the average velocity is not unique, right? Even though I'm looking 0, 1, 0, 2, 0, 3, each time I get a different average velocity, right? Instantaneous velocity, on the other hand, is a specific value at 0. So, how will we calculate the instantaneous velocity? What do we got to do? We got to calculate y prime of 0. How do we do that? At the moment, from the definition. Y prime of 0 is the limit as h goes to 0 of what? Y of 0 plus h minus y of 0 divided by h, by definition of y prime of 0. That's the instantaneous rate of change of y with respect to t. Now, what is that, though? Let's see, if you plug in h, you get what? H cubed plus 2 minus what? 2 divided by h. What do we get? Twos cancel, right? And we're left with h cubed over h. H cubed over h is otherwise known as h squared.
Why did you choose H?
Because the definition of the position function here was t cubed plus 2. So replace t with 0 plus h, which is just basically t equals to h here. Yeah. Oh, and this is what? 0, right? So in fact, the instantaneous velocity is 0. I can understand what's happening graphically. Let me show you what's going on here. So if this is y and this is t, t cubed plus 2 is a simple cubic with y-intercept 2. And it looks something like this, right? So the slope to the tangent line at 0 is flat. Slope 0. In other words, the velocity is 0 because y is position here. But on the other hand, if you look at, say, from here to here, you get that slope. If you look from there to there, you get a bigger slope. If you look from there to there, you get a bigger slope still, right? So the average velocity gets bigger and bigger and bigger as we go farther and further and further out because you're going a larger and larger distance for the given time duration. And yet the instantaneous velocity is 0. As you can almost see from kind of the way the values are going, right? So I'm sure you have some homework problems where you're asked to find a few average velocities and kind of see the pattern maybe as it leads to the instantaneous velocity. Or, if you don't like velocity, y could just be something else, and we're just talking about the average rate of change of some other quantity with respect to, whatever. Y could be cost, x could be number of things produced. So it's like the cost per number of things produced, instantaneous cost, versus number of things produced or something. There's other interpretations. The book will do a better job of discussing that for you than I'm doing right now. So, any questions? Let me give you a problem to try to work out. So here's a problem I'd like you to try to work before the next class. Suppose we have f of x equals to the square root of x plus 2. All right. Try to find f prime of, let's say, 3. Okay. There you go. There's your something to do before the next class. I'll try to come back to that when we start the next class. So actually, if one of you would please remember to write it on the board for me at the start of the next class, I'll write out the solution then. Otherwise, I'm going to forget it. But that's a good example to try to work out, okay? Thanks, guys. Have a good weekend.